Hello students, good evening. Welcome back to my channel. Today, I'm here with my another video and with a new concept, that is data structure. Now this concept of data structure I've divided in three parts, that is in three videos, because it's a little complex and a long topic. Though for ISC students, data structure comes in section C and it has a very less weightage of 5 marks. But this concept is very, very useful and an important topic if you take computer science in your graduation or post-graduation. I hope my video will be a helpful and easy topic to understand. So without a delay, let us proceed. In this video, that is simple data structure, we will cover the following topics. What is data structure and what are abstract data types? Classification of data structures and types of data structures. And in types of data structure, I'm just considering two parts, that is stack and queue. What is data structure? A data structure is basically a collection of elements whose organization is characterized by a set of operations that are used to store and retrieve the individual elements from it. The operations performed on data structures are traversing, that is processing of each element of specific data structure exactly once, searching a particular data element and its position, location from the specific data structure, insertion, adding of new elements from the data structure, deletion of existing elements from the data structure, sorting, that is arranging data elements in either ascending or descending order. Now, what are abstract data types? The term abstract data types or ADT refers to a programmer-defined data type together with a set of operations that are performed on the data. It is called abstract just to distinguish it from built-in data types such as int, char, and double. In other words, the definition of an ADT consists of two main points: the internal representation of the ADT's data and the functions to manipulate this data. In C programming, we can define an ADT by using the keywords type, def, and struct. Whereas in Java, we use the keywords like class and interface. Now, classification of data structure. We can classify the data structure in following categories, like linear and non-linear data structure, homogeneous and non-homogeneous or heterogeneous data structure, static and dynamic data structure. A data structure is said to be linear if its elements are sequentially stored in definite order. In linear data structure, processing of data element is possible in linear fashion. That is, the data elements are processed one by one sequentially. A very good example is array, where all the elements are stored from index position 0, 1, 2, 3 till nth element. Similarly, stack, queue, and linked list are also examples of linear data structure. If the elements are not stored sequentially, rather they are scattered like branches of a tree, then the data structure is said to be non-linear. In a non-linear data structure, processing of data elements is not possible in linear fashion. Tree and graph are the example of non-linear data structure. A data structure is said to be homogeneous if its all elements are of same data type. For example, array. In an array, all the elements of that particular array are of same data type, may it be int, char, double, string, etc. Whereas a data structure is said to be non-homogeneous or heterogeneous if any one or all of its elements are of different type. For example, structure, class, interface. In a class, we can have data members of same type as well as of different type. So thus, an object created of a class possesses a non-homogeneous structure. A data structure is said to be static if during runtime its size and associated memory allocation are fixed and definite. That is, you cannot change the size when it is declared in the memory. A good example is stack, as well as good example is array. And if the stack and queue are used with the help of array or created with the help of array, then they are also static data structure. Whereas if the data structure shrinks, that is, we can reduce the size, or expands, that is, we can increase the size as per requirements, then it is dynamic data structure. For example, linked list or stack and queue using linked list. Similarly, tree and graph, these are dynamic data structure. Array is a static concept, whereas the pointer, object are dynamic in nature. Types of data structure. Here, a complete tree of the data structure is been given, where data structure is divided in two parts, linear and non-linear. I've already discussed in the previous slide. Linear data structure is further divided in static and dynamic data structure. Under static data structure, we have array and stack and queue. If they are created using array, it becomes a static data structure. Array is also homogeneous data structure. On the other hand, dynamic data structure, when a data structure is created using object or linked list, they are dynamic in nature and they can be homogeneous or heterogeneous. So stack and queue, if is created using object or using linked list, they are dynamic data structure, and linked list itself is a dynamic data structure. Next, non-linear data structure. Tree and graph are the examples of non-linear data structure, and they are dynamic data structure as well. In this video, I'm going to discuss about only stack and queue. The stack concept of data structure. In the array, elements can be inserted anywhere, that is at the beginning, at the end, or at any position in between. But a stack is a linear data structure in which this operation is restricted. How? Here, insertion and deletion are permitted only at one end. The LIFO principle is implemented in a stack. A stack is a dynamic data structure as it can grow or shrink. The number of its elements can increase or decrease. This is only when you are using the stack through linked list. Otherwise not. Now you can see in the diagram, this is the stack concept. We have five elements. 5 elements can be stored where the bottom part is being closed, whereas the top part is open. So here we can add elements only at the open end. At the same time, we can remove elements only from the open end. Thus, stack follows LIFO principle, or last in, first out. What all we can do? The basic stack operations. We can perform the following operations in stack. Push operation, that is to insert an element into stack. Pop operation, to remove an element from the stack. Top or peep operation, it returns the element at the topmost position of the stack. Then we have isEmpty to check whether the stack is empty or not. And size, it will return the size of the stack. Though in my video, I'll just discuss about the push and pop operation, which is the part of your ISC syllabus. So, push operation in a stack. What is push operation? The push operation inserts one element at a time in the stack. The push operation in a stack is implemented in two parts. First, the top is incremented by one step, either to top or right, if the stack overflow does not occur, and then a new element inserted at the top or the right position. Here is the algorithm of the push operation given. Now, initially the top always reside at -1 and then it gets increased. Then let us see a pictorial representation of this. So first time I'm adding 10. So push when I'm going for 10. See what happened. Initially top was at -1, top comes to 0 and index 0 is holding 10. Next, another push operation with 15. So the stack will look like this. At index 1, top element 15 is stored and top is at 1. Next push 20 will give this stack structure, top at 2. Next push next I've done 2 push operations at 3 and 4. So here is the 5th push operation with 30. Top will come to the topmost index, that is top at 4. Now if I further want to go for push operation, what happened? That is push 35 I'm trying to do. It will give stack overflow. Next, the pop operation. The pop operation deletes one element at a time from a stack. The pop operation in a stack is implemented again in 2 parts. First, one element is extracted from the stack unless stack underflow occurs. And then the top is decremented by 1 step down or left. Here is the algorithm of the pop operation. Let's see the pictorial representation. Initial stack position. So from the last push function, we get the stack where we have the elements top at 4 and the last element is 30. So first, if I go for pop operation here, 30 will come out. Next will be the next one. So stack after 2 pop operations. So if 2 pop operation done, top will come to 2 with 20 at that position. Next, third pop operation, top will come to 1. That is 20 is removed from the stack. Fourth pop operation, 15 gets removed and top is at 0. Then fifth top pop operation, 10 will also removed and top goes back to -1. If you remember, initially when the stack is empty, top is also at -1. Now when you delete all the elements from the stack, top again goes to -1. Now if I try to do another pop operation, so 6th pop operation, it will give stack underflow. I hope you all have noticed this process. Now, the display operation. Display operation is to display all the elements from the stack, and it will be done from top to -1. Once the stack pointer again reaches -1, the stack becomes empty. Here, let us have an example program. So, a program in Java to implement stack concept through array. The class name is given stack of int. Data members or instance variable are int num, int top. Int num is the array here, and we have taken the size of 5 to make it short. Then we have a default constructor where top is set at -1. Push operation, it will push one element at the stack to the stack. Pop operation, delete one element, and that will be returned. If no more elements to delete, it will return -999. Then give a display operation, and finally in the main method, create a object of the stack. So we are now in the BlueJ platform. and I'll show the program, the solution of that question, and go through line by line, explaining each statement. So here we can see the class stack of int having one integer array and a top variable. The default constructor is initializing top with -1. And as it was mentioned in the question, the array is a static element of 5. The array is storing 5 static elements. Now let's come to the push function. In the push function, insertion operation will be done only one element at a time. So as top is at -1 initially, first we'll do top increment. So top plus plus or plus plus top, whatever you want to do, you can do. And then num top equals to the value, you're storing it. Now here there's a condition. If top reaches the size, suppose we have an element here, the array is of size 5, so top reach 5. That means the stack is full. So either it is stack is full or stack overflow, as whatever is mentioned in the question will be displayed. And here I'm doing top minus one time. Why this I'm doing? Because once you're trying to add an element and already your stack is full, that means you are at the last index. Now, when you are incrementing the top, it will go out of the index in the array and it will print stack is full. Now we need to come back to the last element once again. That's why I'm doing top minus. Now the next function, pop, what pop function is doing, it will remove one element from the stack at a time. So here we do int s equals to num top, top minus minus, and return the value. That is where the num top is stored. If top reaches -1 again, then stack is empty or stack underflow. And here you have to return a value, whatever will be mentioned in the question. Generally, it is -999. Now, these three lines, that is int s equals to num top, top minus minus, and return s. These three can be combined together in one line, right? And the statement can be like this. I'm writing it as a comment, or return num top minus. So you can do this in either in this forms, making it in 3 separate lines, or in one line. Further, in the display function, if top is already at -1, nothing to display. Otherwise, the loop will run from top to 0 and element will be printed. Now, I have done the main method. What is there in the main method? We are creating an object of the class stack of int. Now I'm running a while true loop where I'm taking each number at a time and asking whether you want to continue. If my top value reach 4, it will not add another chance, not give another chance to add, because stack is already overflow. Then we have the display function to display the stack elements. And then finally, I'm calling the pop function again in a while true loop and displaying after that. So let us compile and run this program. Let us run this. So it's asking a number. Let us take 10. Yes, I want to add another number, 11. I had to add another number, 12, another number, 13, another number I'm adding, 14. So see, we have added the element 10, 11, 12, 13, 14. So when I'm displaying, it is displaying in the reverse order, 14, 13, 12, 10, 11. Now when I've popped, the element popped, first 14 is being removed, top position from 4 come to 3, 13 removed, top come to 2, 12 removed, top come to 1, 11 removed, top come to 0, 10 removed, top comes to -1. And then if one more pop function asks to execute, it will give stack is empty. Finally, my display function, when I once again invoked, and it is showing stack is empty. So this is all about the stack program. Let's move back. So we move on to the next concept, that is queue. A queue is a data structure with FIFO paradigm. It is implemented either in an array or a linked list. The queue is a collection of data elements in which all insertion are made at one end, called the rear end of the queue, and all deletion are made at the other end, called the front end of the queue. Typical characteristics of queue is that the first element to be inserted into the queue is the first element to be deleted. So you can see here a figure, queue data structure. Insertion or enqueue operation done at the end, and removing or deletion done from the front. It is just like a normal queue. It can be a queue for a railway ticket booking or any other queue where the person comes and stand one after another. And when the counter gets opened, the first person moves out, the second person comes to the counter, he becomes the first now. Then he moves, next person comes to the front. So whoever is moving out, the next person becomes the front person, and whoever is joining the queue becomes the rear person. So we can add one element, we can add elements only at the rear end, and we can remove elements only from the front end. Thus, queue follows FIFO principle, first in, first out. What are the operations we can do? So the basic queue operations are enqueue. This is the process of adding or storing elements to the rear end of the queue. Del queue, it refers to removing or accessing an element from the front end of the queue. Is empty to check whether the queue is empty, and is full to check whether the queue is full. Though in this video, I am discussing about enqueue and del queue operations. So insert operations, that is enqueue in a queue. The insert operation inserts one element at a time in the queue. The enqueue operation is implemented in two parts. Rear index is incremented till queue overflow does not occur and new element is inserted. The algorithm is given over here for enqueue operation. Let us see a pictorial representation. So simple queue enqueue operation. Let us take a queue of size 5. Here initially front and rear resides at 0 and the entire queue is empty. In the beginning, when the queue is empty, both front and rear points to 0. When the first element is added at the queue, let's see what happened. 10 is inserted and rear moves to 1. So rear from 0 moves to 1. Front remain at same place. Next in queue, I'm adding 11 to the queue. Rear moves to 2. Next, adding 12, rear comes to 3. Here you can see the rear points to the empty cell, next empty cell after the last entry. Thus, rear always point to an empty cell in a queue. So when we enqueue 14, rear reaches the last index. Now the queue is full. Now here we have to keep in mind, if the front and rear starts from 0, if the array is of size 5, we can store only 4 elements. One cell, the last, should be left empty in a queue. Whereas in stack, an array of size 5, we utilize the full array. Whereas in queue, I am leaving one element. Here, the rear reached the last index. The queue becomes full and no more entry allowed. Now, del queue or delete operation. Delete operation deletes one element at a time from the queue. It is also implemented in two parts. One element is extracted and front index is incremented by one step. Here is the algorithm. For del queue operation, it can be termed as pop operation also. Del queue, enqueue, push, pop are now, they are not keywords. They are just name. It can be given any name. pictorial representation of del Q operation. So from the last NQ operation, we found the queue is full with front at 0, rear at 4, and the elements stored are 10, 11, 12, 14. Now, initially the queue is full, so the front is at 0 and the rear is at 4. Now, at first delete operation, front move forward at 1. So you see, 10 gets removed from the queue, front comes to 11, that is index position 1, rear is at 4 only. Next del Q operation, 11 get deleted, front comes to 2, rear remains at 4. Here you can see one element removed from the queue and the front moved one cell towards the rear. Rear remains same at its own position. Next del Q, 12 deleted, rear comes to, front comes to 3. Further, another del Q operation, 14 get removed, front and rear both comes to the same index position, that is 4, and Q is empty. So when the front and rear points to the same index, it means the queue is empty. Initially, during NQ operation, you also have noticed front and rear at 0. So queue is empty. Now here also the queue is empty. Then the display operation, we have given the algorithm. It will start from the front position till the rear position and front get incremented every time. Now let us see an example program to implement a queue. Again, a mistake has been done. To write a program in Java to implement queue concept through array. It's not stack, sorry for it. So the class name is queue, data member, int AR, and in a queue of integer to store 5 integers in an array. Then here we have 2 pointers, top and rear. Front and rear. Front stores the front index of the queue, rear stores the rear index of the queue. Member functions, default constructor, and here front and rear will be at 0. Then NQ operation, del Q operation, and display operation. So let us see the program. So now we are in the Q program. As in the question it was discussed, here the Q is an integer array of size 5, and there are 2 pointers, front and rear. Front will point to the front index from where the elements will be removed, and rear will point to the rear index where the elements will be added to the queue. So we have a default constructor. Here front and rear are initialized with 0, and the array is allocated with the size of 5. Now in the NQ operation, if rear reach 4, my queue is be displayed as full. And otherwise, what I'm doing, I'm storing the element at ARR rear and then rear plus plus. Now you can see I've combined that in 2 statements in one line. That is ARR rear plus plus equals to n, which means first at ARR rear, the element n will be stored and then rear will be incremented to the next index. That means in any case, rear will point to the next empty cell after the last entry. And that's why in this array of Q, we will see the last index is left empty. Now the del Q operation, in the del Q operation, what I have done, if front is equal to rear at any point of time when the front and rear both points to the same index, it means the queue is empty. Now when the queue is empty, it will return -999 or whatever will be asked in the question to return. And very important part is we have to reposition both the pointers to 0. Front equal to rear equal to 0. And if we don't do this one, then in that case, the queue will become inactive and we cannot use the same queue again. Since rear already reached the end element, it will show queue is full, and rear front also reached to that element, it will show queue is empty. So if you don't reposition front and rear in del Q operation, if the queue is empty, you cannot use the queue again. If front and rear are not at same place position, then what I'm doing, it is returning ARR front plus plus. Now see two things. In the NQ operation, it is rear plus plus, whereas in the del Q operation, it is front plus plus. That means in both the cases, we are using incrementing. In compared to the last data structure, that is stack, where we have one operator pointer top. When I'm adding element to the top get incremented, and when you are deleting from the stack, top get decremented. Here, both are incremented. Now the display function. In the display function, if front and rear both points to same element, initially both are at 0 means queue empty. And at any place, when the queue is empty, again both goes to 0. So we can make if front and rear equals to 0. That also we can do. Queue is empty. Otherwise, the loop will run from front till less than rear, because rear point to the last empty cell. I'm printing the LED. Now in the main function, here again we are creating an object of the array Q. Sorry, the class Q. We are running a while true loop. Inside that, I'm taking each element and adding it through NQ operation. When it reaches 4, it will automatically, the loop ends because Q becomes full. Then we are displaying the Q elements after all elements being added. Then I'm again running a while true loop. Here we are doing del Q operation. And if the del Q operation does not return minus 999, it is printing the element that is deleted from the front position, whatever the index it will be. Otherwise, the loop ends. So let us run this program and see what will be the output. Main. So the number to be added at rear is initially at 0. So added at 0, let us do 10. Then at 1, I'm reading 11, then 12, then 13. Now, if you remember in the last output, in the case of stack, we stored 5 elements, 10, 11, 12, 13, 14. But here in case of queue, if the queue is of size 5, I'm only adding 4 elements. Now, when the elements are added, it is printing 10, 11, 12, 13. Now again, when I'm deleting the elements using del Q method, it is deleting the first element, that is 10 is being removed from the front position 1. Then 11 is removed from front position 2. 12 removed from front position 3, and 13 removed from front position 4. And thus the queue becomes empty. Next part. The difference between stack and queue as a data structure. As you can see, stack is a data structure that follows last in, first out technique, whereas queue follows first in, first out technique. Stack requires only one pointer called top, whereas queue requires 2 pointers, front and rear. Top is responsible for insertion as well as deletion operation in stack, whereas in queue, front is responsible for insertion, whereas rear is responsible for deletion in queue. After deletion, if the stack gets emptied, top remain in its own position. But here after deletion, front and rear need to be placed at 0 or minus, whatever be the initial value at the time of starting the queue. Now the operational areas of stack are recursion, arithmetic evaluation, parenthesis evaluation, reversing a string, infix to prefix and postfix. This topic I'll cover in another video for you all. Operational areas of queue are printing sequence, CPU scheduling, parallel processing, BFS and DFS in graph. So that's all from my end in this video. I hope it will help you to understand the concept of stack and queue. In my next video of the data structure, I'll cover the different variations of queue, and then the last part of the data structure, that is the linked list. Thank you. Good night.